Hey guys, so today we're going to be going over the four types of operons. This is all information from chapter 12 of the book. So, what we're going to need to know to talk about this is an inducible operon, or is an operon in which the transcription is normally off, but then something occurs that turns it on. This is usually used to control proteins that are involved in degradative processes. This makes sense because you normally want proteins that destroy things to be turned off unless you have something around that it needs to destroy. And so you would want transcription to be off unless something was in the area that needed to be broken down. Repressible operons, this is where transcription is normally on. However, something must occur for it to turn off. This is usually used to control enzymes and biosynthetic pathways. This makes sense because we're always using our biosynthetic pathways. These are types of pathways that'll help us survive pretty much, and so we need these enzymes to be active unless there's something going on that needs to have them turned off. And so it makes sense that these are transcription for these enzymes are always on. We also have positive control, and this is a system in which gene expression is turned on when an activator protein is bound. And then we have negative control, and this is a system in which enzyme expression is off when a repressor binds. So now that we know all that, we can go look at a negative inducible operon. So negative, we know that this means that when the repressor is bound, transcription will be turned off. And inducible, we know that that means that when something is present, transcription will be turned on. And so if we're thinking about what's going on right here, we know it's negative inducible protein because when it binds, it turns it off. So then we know that's negative. But we know that when there's a substrate around, it'll bind to this, and the substrate will actually turn transcription on, which means inducible. And so based off of what happens in the presence or absence of the substrate, we know that this has to be a negative inducible operon. Negative repressible, so again we know negative means that we need to have the repressor bind to the DNA for transcription to be turned off. And repressible means that we need to have the product will actually stop transcription. And so if we're thinking, okay, when the product is there and it stops transcription, and negative means that the repressor is going to bind to stop it, that means that we're going to need the product to help it bind for it to overall stop. That makes sense again with what we know about negative and repression, because when the product is not there, the protein cannot bind to stop it, and so this will always be on then. Okay, so now if we're talking about positive inducible, positive means that we need an activator to bind for transcription to be turned on, but inducible means that we need to have a substrate present for transcription to turn on. So for both of these to work together, we need the substrate to bind to the protein to allow that protein to bind to the DNA to turn transcription on. Otherwise, without that substrate, the protein can't bind, and so transcription is off. So positive inducible here means that the substrate will bind to the activator to allow transcription to occur. Finally, positive repressible. Positive again means that we need to have the activator bound for transcription to occur. Repressible means that when a product is present, transcription is going to be turned off. And so if we have the product present, it's going to be binding to the protein to stop, to make it stop binding to the DNA, so transcription cannot occur. So when the product is not available, the protein will bind, allowing transcription to occur. And so positive repressible means that the product will bind to the repressor to make it inactive, stopping transcription from occurring. I hope this kind of cleared up what is going on with these four different types of operons. It's really easy to understand how all of this fits together and what has to happen if you break down what the two words mean and see how they work together for transcription to be on or off. If you have any questions, feel free to contact Dr. Grunda or me. Thanks so much.